Okay, if you want to do an assembly, you start off going very similarly. You go to the analysis GUI or the analysis menu to the structure submenu, and you pull up the assembly. And like I said in the last talk, assemblies are made from one or more structures. And then what we can do is we tie them together with rigid links. And then when we write out the FEM file, it then gets written out to one combined FEM file with all the node numbers appropriately offset from one another. So to start with, you create the assembly on the assembly tab, you give it a name, and you just say add assembly. And like before, that's going to become the active assembly that you're currently working on. On the structures tab, you then manipulate the list. You need at least one structure to make an assembly, but you can have as many as you want. And so here you just go through and you add however many structures you want in your assembly. Either add them one at a time or you can add them all. And then you work on the connections. And this is, just creating a connection between, a fixed point, some node in one structure to a node in another structure. So again, this would be like attaching a hard point at the root of the spar of the wing to a hard point on the fuselage in order to transfer loads between those structures. The way we do that under the hood in Nastran is right now we write RBE2 elements, which are rigid beam elements. And in Calculix, we actually use the equation command. And equation actually goes in and modifies the stiffness matrix to equate those degrees of freedom. You have some ability when you do this that you can actually go in and tell it, when you make that connection, what are the degrees of freedom that you want to connect. So you can use this to create, different kinds of joints when you are making an assembly. The FEM model looks very much like the FEM model under an individual structure. But what we can do is down here at the bottom is we have the ability to remesh everything or to mesh just the structures that have been unmeshed. And then we can come in and we can visualize and look at that combined assembly, including, looking at different element sets instead of the whole thing. And that writes out that FEM file. So assemblies are pretty straightforward, just as an outgrowth of individual structures. There's one more sort of capability in here, and this capability is simple and it's going to be evolving. I'll just put it that way as we go to it. We have some ability to set up a combined Aero structural analysis. So the idea here is under the Aero structural menu is we will apply loads from VSP Aero onto your structure or your assembly. And part of the reason this is evolving is I don't think that the load mapping from VSP Aero's loads to the structure's loads, that's done by a tool in VSP Aero. And I don't think that tool has been updated yet for all the changes that we've made going to things like, NGON meshes and all these other updates. And so this capability is going to lag behind a little bit. So basically, I expect this capability to break when we release the new VSP Aero, and hopefully we'll get it fixed. Underneath, what we're really doing is we're applying those loads, and then we're helping you run Calculix. Right now, it's only set up for Calculix, and it's set up to help do that. It requires the Calculix solver, CCX, and VSP will search for and find that on your hard drive. And if you have the Calculix visualization, CGX, it'll also do that. And the general idea here is really just to sort of be kind of like a wizard, a semi-automated process to help you through doing an aerostructural analysis. And so the way this works is really you work top to bottom through this GUI. And basically what it means is it shows something in red if that step has not been done yet. So things that are in red are not done yet, and things that are in gray cannot yet be done because their prerequisites are not satisfied. And so what we really do as we start, you're going to need the loads first. So first you have to execute VSP Aero. If you haven't done anything, that button's going to be red. Once you've executed VSP Aero and it then has a set of loads, that will then no longer be red. You can come back and you can rerun it later, but it at least knows you have a set of loads to start from. Then you pick which structure you want to work with, and you choose the structure. And then you can either show the structure GUI or the assembly GUI, and you can mesh it. If it hasn't been meshed yet, that's going to show as red. And if it has been meshed, then they'll show as gray. Once it's been meshed, then you have to export the FEM file. And again, it's grayed out right now because in this very initial case, it hasn't been run. But once it's red and you can click it because you've meshed a FEM mesh, then you can export it and it'll write that file. Once that's written, you have the option, you can visualize it. And so you can take a look at that mesh, see if it's what you want. Next, you need to transfer the loads from the VSP Aero solution to the mesh. And again, this is only possible to be done if the mesh has been written to file and if VSP Aero has been run. And so if both of those are true, then you tell it what your dynamic pressure is, what Q is, and that's used to dimensionalize the CPs from VSP Aero into pressures for the FEM solver. So if this button is available, you apply the loads, and then if you want to visualize that again, you can visualize the loads on the mesh, and you can go look at that pressure distribution. If all of these things are true and all these things have been satisfied, then you can actually solve the solution. You can solve the FEM case. And so if that's possible, then that button will be not grayed out, and you can click on the button to solve the structure, and it'll go and run the solution. And then if you have a solution, you can then visualize it. You can either visualize the results in CGX or you can visualize them in the VSP viewer. So each of these is really just executing a command line. All these calculus and viewer things are really just executing a command line. And so the equivalent command line is shown here in this window. And again, this is really just a sort of a wizard to help you get the flow top to bottom through this process. There's no magic happening here. And hopefully we can get this working again soon. So with that, I have a little bit of time. I can go do just a very, very brief demo of some structures capability. And I can also, if anybody has questions in the background, I'm happy to try and address those questions. Okay, so to start, I'll just come in and I'll add a structure to a wing. And I usually work with just half the wing when I'm doing structures, but Brian, who's actually a structures person, definitely does not. So there's your first clue that I don't know what I'm doing. But I'm going to come in here and come into structure. And I want to create the first structure, so it's based on the wing. So we'll add that structure right here, and we can call this wing main structure. So now we've created a structure based on this wing. And if we want, we can set the orientation. So that's going to set it to a top view. And it's also going to, put it in this sort of gray, just so that we can see the layout. We can come into the parts. And again, we have all of these choices. We'll start by adding a couple of ribs. We can edit that part. And as we said, we can move that part. Here's the location. We can move that part inboard. We'll just add a couple of ribs very quickly. Okay, so we've added a handful of ribs. And then I'm going to add a polyspar. And so you can see here, again, this is new. The polyspar is defined by the points in that polyline. So we have a start point and an end point of this spar. And, we no longer, it doesn't have to go all the way out the wing. It can now, come out just a partial extent of the span. Or if it goes all the way to the end, we can insert another point before, and that'll be that midpoint. And that point, we can then come and we can move that around, right? So now we can independently control where that point happens along that wing. And of course, all of this is, with respect to the wing that's currently active. So we can come in here to our wing, we can split this wing, for example, and then we can increase the root chord. So here we have, maybe not that far, let's not go crazy, but let's reduce that inboard span. So here we've got, a cranked wing planform, and we can go back to that structure and we can come to this default point, and now we can dial in that eta for this polyspar. Or if we don't want to work in terms of eta, and we know that, okay, we have our cross sections, 0, 1, 2, 3, whatever that is. If I place my eta close to that planform break, and I know that's where I want it, I can just switch here to U of N, and I know that to put it exactly on that planform break, I just set it to 2. I'm going to turn that off so we don't have the bounding box. So that's how you define a polyspar out that wing. And really, my recommendation on many of these things in VSP is to start simple and mesh early. So I'm going to come over to the mesh options before I add anything else. We're generating quads by default. We've got our 0.5, all of our default settings. I am going to change these to relative, and that tells me that right now I'll change that to 0.05. So we'll have about 20 elements out the span. And let's just go ahead and intersect and mesh. And here we have our first fem mesh generated for this structure. As I said, it's in quads. We can kind of see what's going through. The fun part comes when you come to the fem tab, and you can now actually, do this visualization. So first, we're not deleting it. We're not changing the mesh. But if I just don't want to see the skin, I can turn off the skin, and that very quickly allows me to see the ribs and spars on the inside. Right now, they're colored by part number. You can see they're colored here. If I turn off the mesh, we only see the colors. I can also, as I said, we can tag it, we can color it by the reason. And let's turn the skin back on. So in this case, what this is telling us is that most of this mesh is, its edge length is determined by this baby blue, which means it is based on the growth ratio, but based on the number of circle segments criteria. So the blue column is all about that number of circle segments criteria. These dark blue edges are set by the number of circle segments criteria, but they've run up against the minimum edge length constraint. So if you want them smaller, that means you need to make the minimum edge length size smaller. Where we're here with this middle blue, that means that we're being set just by the number of circle segments. Back here in the red, that's where we've hit the maximum edge length. So the maximum edge length is only active back here. And that tells you just exactly what's determined the edge length for every node. So if you're playing with your meshing, this helps you figure that out. Okay, let's not color it, and that way we can just see those elements. And as I said, we can come in here and we can turn off the skin, and we can look at the rib and spar and all those elements there. So that's a very simple structure. We can come in, we can add more parts of all different types. Let's add another polyspar. Here we go. And this one, let's move its start point. Let's make it an aft spar. So we'll move it back here. We'll do the same kind of a thing. We'll insert another point before there. And this one we'll do the same thing. We'll break it at the planform break, and we'll bring it back to its X over C of same kind of region, and then we'll go to the end and we'll dial that back. So now we have a forward spar and an aft spar. And then next, what we'll want to do, and let's reset the part display. Oops. There we go. So let's reset so that we're just looking at the part display. And now let's add, for example, a trim. So here we'll add a trim. And like we said, we want to trim, and we choose which parts we want to trim by. So we'll trim by the aft spar, and you can see the arrows pointing forward. We don't want to do that. We want to trim aft of the aft spar, and then we want to trim based on rib 2 and rib 3. And so here you'll see they're both pointing outboard. Rib 2, I'm okay with that, but rib 3, we want to flip that direction. So now if we do this trim, we're going to trim out this segment. Actually, let's change that from rib 2. Let's delete that one, and let's make that rib 1. Okay, so now we're going to trim everything outboard of rib 1 and inboard of rib 3 and aft of the aft spar. So if we generate that mesh, you'll see that we've trimmed out and we've cut out that part of the structure. So that's how trims work. You know, we could go through, we could define subsurfaces, we could apply fixed points. There were some questions. The material properties are specified here. We have these materials built in with this note. So if we add a material, Andy, to your question, you can type in your reference, you know, you can put whatever note you want in this box. So you can name your material and define those material properties. But so that's here to define the reference. This is sort of like attributes before there were attributes. You can define your laminate schedule. So to do that, you first have to add a material and set that material to be a laminate type. And then that material, you know, this is going to be my laminate. Then we're going to come over to the laminate tab and you're editing your laminate where you then add your lamina and you can then specify their thickness and their orientation. And so you can say, okay, I want this to be a carbon and balsa laminate. So we can add that and then say, okay, here's my, oh, this one I wanted it to be, that one was carbon. Yeah, that's fine. So there we go. So now we're carbon, balsa, and you know, and then say add another layer, and that one would be carbon again. So we've got a carbon balsa sandwich with 1/10 of an inch thick layers. Those are really thick carbon layers. So that's how you build that up. Properties, you come over here and you always need to have a default property, but it'll create a default if you don't have one, and then you can create all of your others, and we can go on through. I'm going to cut this off so that I give Brian as much time as we can. Oh, actually, we're up against the break, not Brian yet. So I will still cut it off so that we can go and the East Coast can have lunch, and I will, you know, see you back after the break.
Sounds good. Thanks for the demo, Rob. I know everybody really appreciates walking through, especially something as complex as the FEA structures and assemblies, that we get to see kind of a hands-on approach of how this stuff all works. So when people really see what you can do with it, it's pretty incredible.